All right, so I'll do a couple of example problems off of each of these. I think we pretty much covered all the material I needed to cover in class of the night. I don't think I did enough example problems. So when you go to do the examples, you're going to be like, well, I'm not sure I can do it or not. So that's kind of my plan to fix this tonight. So I'm going to do this problem here just because it looks fun, I guess. Why not? So it says if S is this set 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and A is 0, 2, 4, 6, and 8, and B is 1, 3, 5, 7, 9. And C is 2, 3, 4, 5. Oh, good night. 3, 4, 5. And D is 1, 6, 7. Awesome. Awesome. There you are. So in other words, our sample space is all the numbers 1 to 9. And so A, B, and C, and D are these sets. Lovely. It says, what is the union of A and C? That is, what is A or C, in other words? Well, of course, that would be, let's see, you got 0, of course. They both share a 2. They need a 3 because C's got a 3. They share 4. Need a 5 from C. They share, don't know, we got a 6 and we got an 8. That take care of everybody? Well, 2, 3, 4, 5, check. 0, 2, 4, 6, and 8, check. There it is. How about A intersect B? Where do A and B overlap? Well, not 0, not 2, not 4. Oh, geez, they don't. It's the empty set. They have nothing in common. Or if you prefer, I like this. But you do you. I don't care. How about C complement? That is something we did not talk about in class tonight. Mr. Groom totally blew that off. This guy, or it could be, you could also write like, sometimes some books will write like this, and some books will write C complement like that. Don't really care. Your book chooses to use this C that way. The complement of C is everybody but what's in C. So you need 0, 1, 6, 7, 8, 9. That takes care of everybody else that's not in C. That's another way to say C complement is not C. Okay, this part here is pretty cool. It's not C and D or what's in B. Okay, so we gotta do this guy first. What is the intersection between not C and D? Well, the intersection is 1, 6, and 7. In other words, the intersection is just D because D, we say, is a subset of C complement. Okay, so this part right here is just D, in other words. Okay, so you've got 1, 6, and 7, and we're going to take that and we're going to marry that with this guy. So these two go together. And so, of course, you need a 1. They share the 1. 3, 5 I need because of this fella. Need a 6. Hey, we share a 7. And, of course, we need a 9. Again, we say that D is a fully contained subset of C prime. In other words, it's fully nested inside of it. Okay, this is a fun one. S and C. Oops, what are you doing? What in the Sam Hill just happened here? I don't know. Delete. Maybe. And delete. Oh, fiddle faddle. That's not good. Don't know what this is. Not sure why it's here. Don't really know. Don't care. I'm going to move it in here. So S intersect C. Take the complement of that. Well, now hold up. C, or S rather, is the sample space. C is a component of that, so we're looking at not this. Okay? Not that. Okay? So you could say all numbers. You could say all numbers except 0 to 9, which is what most people would think. Or is it 0 to 9 or 1 to 9? 0 to 9. Most people would think that, but here's the deal. Your book probably going to ask for just this, the sample space, because there's nothing left besides those guys. Okay, I would take either one. I would never give you one that's got goofy on the test, because you're just like picking on people at that point. A intersect C intersect D. Okay, this one here I'm going to look up here and let's write them down. So there's A, C, and D. A and C and D. Well, if you look at this, where do those guys intersect? Well, where does A intersect with C? Well, 2 and 4. Okay, so I'm going to write that down, 2 and 4. Okay, that's the first one. That's this bit right here. Now, let's see where that intersects with D. Well, D is 1 and 6 and 7. So, the only thing that they have in common is, they got nothing in common then, don't they? Okay. Now, some people go, wait, does it matter what order it is? That's a good question. Let's find out. If I did C and D first, what do they have in common? Nothing. They have nothing in common. So what does the empty set have in common with A? Let's see, nothing. So once again, the empty set would be your final answer on that guy. Remember, anywhere you see intersection is and. Anywhere you see union, of course, is or. Cool. Let's do one of these fellers here. So a drug for the relief of asthma can be purchased from 5 manufacturers, and they each come in liquid, tablet, or capsule. Liquid, tablet, or capsule. Nice. And and they can all come in regular or extra strength. And so the question, of course, is how many different ways can you buy the stuff? Okay, well, 5 times 3 times 2, you can buy it in 30 ways. Again, that's a fundamental counting principle. Okay. All right. Number 40 here. How many ways can the 5 starting position on a basketball team be filled with 8 guys who can play any position? Okay, you got 8 guys, 8 people. You get 5 positions, and they can play any position. It's one of those questions where, whoo! It's one of those questions where I think a little ambiguity is nice. Personally, I like a little ambiguity in my question. It kind of helps me think about it. Some people might go, well, it depends. Well, what do you mean it depends? Are you saying that if I take Bob, Fred, Pete, those 5 guys put them on a court, they're the same 5 guys, whether Bob's playing point guard or whether Bob's playing center? And if you think that's true, then this becomes a combination. If you think it's a different team with Bob at point guard and Jared at center versus if Jared's playing the wing somewhere, well, well, then in your case, that's definitely a permutation. I like questions like this for the test because if you're not sure, you'll come to me and I'll go, I don't know. Well, it kind of depends. I go, well, you better tell me what it depends on. So again, if you believe that Fred, Pete, Joe, Brian, Mike, whatever, if you believe that's the same team, whether or not they play different positions or not, because they can all play all the positions, if you think that's true, then it's simply 8, choose 5, which if you're playing along at home, 7, 6, 5, 4, 3, 2, 1, over 5, 4, 3, 2, 1, and you get, I don't know, I can't do math, 56 times 6, which is 336 ways to pull that off, if it's a combination. If it's a permutation in your mind, of course, you better tell me that, oops, Daisy, I lied to you. If it's a permutation, it's 336 because it's 876. That's all that's left when you do all this business here. If it's a combination, you also have 8 minus 5. Oops, I screwed that up. Let's try that again, Jay. Let's just do it right this time. How about you just do it right, stupid? There you go. If it's a permutation, it's 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 8 minus 5, which is 3, 2, 1. And so you've got, well, let's see, you've got 20 times 6 is 120 times 56, 6720. Okay. If it's a permutation. If it's not a permutation, then it's 8765. All right. 4. Divide by, because all the rest of this canceled off. Divide by, then 5 factorial, which of course is 5 times 4. 5 times 4 times 3 times 2 times 1. Of course, you can use your calculator for this. I do not care. There's 20, there's 20, there's 6, there's 6. There's 56 ways to pull this off. Again, that's one that I really like that kind of question to come up with. Yeah, there it is. Even though they can play all the positions, are they equally as good? No, of course not. Of course not. Are you just as equally likely to play them in any of the positions? Probably not. Okay, I used to play with a bunch of guys at school here. Well, this was, okay, now back to train up. This was 15, 16, 17, 18 years ago when I was younger-ish. So I got height. I was faster and athleticer then. But yeah, depending on who we were playing against, who was on my team, okay, then, you know, okay, well, Jay, you're you're the best of what we got here, so you go guard their good guy. Great. Great. Well, I'm gonna need a little help, fellas, because I'm not good enough for that. Okay, Jay, there's a 6'8" guy showed up to play today. I guess you're guarding him. Yeah, okay, I guess. So, obviously, there's better and worse positions for some of us, even though we could quote unquote play them all. So, again, keep that in mind always. Just because they're possible outcomes doesn't mean they're likely outcomes. All right? Just because they all exist in theory doesn't mean they are equally likely. One that always comes to mind. You know, some years there's this Danica Patrick when she used to race cars back in the day, and she never won a race in NASCAR at all, and I think she won one in IndyCar. And people would always be talking about, well, is she going to win? Is she going to win? Well, she never came close really to winning except for that one race. And so it would just be like every week, do you think she's going to win? No, no, probably not. Was it theoretically possible? Yeah. Were I going to bet money on it? Maybe not. One story that I didn't get to tell last week in class, and I'll probably tell it again at some point, maybe something similar to it, because it happens so often. And that is when we start talking about statistics, when we start talking about probabilities, okay? Most of you grasp this concept because the whole concept of what we talk about independent and dependent events, we're talking more about that next week. Sometimes, if you know, whether I dropped out of high school or not, that, you know, that has some impact on my future plans in life. Okay, that we say my future plans are dependent on my education, right? Or lack thereof, I suppose. So that's cool, I guess. But when it came to mind, and I was doing this at a PCC, and this lady got all mad about it, and it really hurt my feelings. Well, it hurt my feelings. It irritated me. I had to go to this meeting. But I explained to her that there are some cars that are more likely to be driven by, and at the time I always talked about, hey, you know, there's some cars that just scream people, like, for instance, a PT Cruiser. So I said PT Cruiser, and she blurts out, it's an older woman who's divorced. And I was kind of like, they do have kind of a following about, yeah, okay. And so this is in front of the whole class. She's the one that's blown all the answers. I said, what about a brand new Porsche? It's an old man. And I go, well, ouch. But yeah, probably. Why? Well, because young men can't afford them. It's probably a short guy too, no offense, but I don't fit in them, so I'm not buying one. It's because somebody's got money and wants to try to prove something to people or show people he's got money. Yeah. And ladies typically don't go out and try to impress people by buying a fancy car. They go out and try to impress people other ways, and that's fine. We are all different. And I said, "What about a pickup with a ladder rack?" Oh, yeah. And she says, "Oh, it's probably a man." I'm like, oh, "Okay, whatever." So we get down. What about Toyota Camry? Well, everybody drives a Camry. Oh, yeah, I guess you're right. So we started laying it out, and I drew a box on the board. So I said, "Here, men and women, and all these different kind of cars." And I said, "Does it look like it's the exact same ratio in each one?" And she's like, "No." And I said, "Well, what that means is what you drive is dependent on your gender to some degree." And she got all butthurt about that. She's so mad. And I had to go have a meeting with my boss because I triggered her. And I said, "Listen, it's literally," I told my boss, I said, "You understand, literally, there's a whole thing called demographics." Okay. That's how Giggle spies on you and knows exactly what ads and stuff that you're going to want because they know you and you're very much likely to pick these things. Um, and so it's not impossible that Jay Groom, who's into tractors and farming and cars and you know that sort of thing, current events to some degree, history. I dig history. It's not impossible that I would watch some, I don't know, Teletubbies YouTube clip or something. But I think that the algorithm realizes it's wasting its time suggesting that to me because it's unlikely, even though it's possible, it's unlikely that I'm into that. Instead of like, oh, geez, you watch this, and this. Hey, I bet this car one here will turn you on. Nice. You watch this thing here and had a tractor pulls in it. And you're like, oh, I bet you'll like this one. And once in a while, it'll suggest something that seems at first blush to be out of the blue and kind of weird, and you're like, hey, I think that does look interesting. And why is that? Because everybody else who watches the same sort of thing I would watch on YouTube is digging that too. And so it's pretty cool the way it works, right? So this concept that we're going to spend some time on next week quite a bit, this concept of independent and dependent events, we're going to spend quite a bit more time on next week, is a pretty big deal because in our daily lives, a lot of what happens to me is very much dependent on something, right? Oh, you're late to work. Oh, you got your butt chewed at work. Oh, why? Well, I was late again. Well, bro, that's dependent on your actions. That's how this works. Oh, you got a ticket? Well, what were you doing? I was driving 90 and a 30. Okay, you're an idiot. Et cetera, et cetera, et cetera. There are things that happen that happen, right? This lady a while back, she got all mad about, well, I just can't believe my car has a problem. It only has 100 and whatever thousand miles. I'm like, okay, yes, but I can't believe this happened. I can't believe it. There's a lot of things in life that just happen. Whoops, oh, there you go. And I can't account for it. I can't. There's nothing to do about it, right? So I mentioned the day I went to a tow where a guy was killed by a deer that literally jumped into the car with him, right into the windshield. That's independent. That's independent. You could go, well, if he'd have left for the rest of the store 10 minutes, 5 minutes, 30 seconds sooner. Well, you'd be ifs and buts were candy and nuts. That doesn't work that way. It's a completely independent event. And there's nothing you can do about it. You can talk about the butterfly effect or this or that. Okay, I guess. But in reality, there's nothing you can do about it. Right? Oh, did you run over a nail? Oh, okay. Well, there it goes. Some car kicked up a rock and hit you in the. Hey, there's nothing I can do about that. It's completely independent. Obviously, we can't prepare for independent events in terms of like what's going to happen to me. You can keep your head on a swivel and be aware that these things can happen. You could leave early knowing that you might get a flat tire. And so if you left early enough every day, even if you got a flat tire, you're unlikely to be late. You get up earlier. You can do things like that to be prepared. But there's nothing you can do about whether you get one or not. It just happens, right? Same with insurance, right? I can't guarantee I will or won't get sick, but I'm going to have insurance in case I do, right? That's independent. Now, there's some things, obviously, oh, I'm a heavy chain smoker. I can't believe I got cancer. Really? You can't? Really? Really? But, things happen, right? People get diseases, and there's nothing they do. They didn't do anything to get the disease. It just, there it is. It happened. Okay, even if it's hereditary, nothing you did to do it. Now your parents can be blamed. How did you not know that putting two of you together? I don't know, right? But that's different, and it's really not. It's not a thing, right? So independent, dependent events. We'll talk more about that next week. Not really sure where I was going. Oh, I was going back to that with this saying that just because they're possible events doesn't mean they're likely events. And because why? Because winning a race, for instance, depends on how good a car you have, how good a driver you are, that sort of thing. I think that's where I was going. Sometimes I talk and then I'm like, oh yeah, that's right. Oh duh. Boom, boom, boom. Nice. I like this one here. Suppose in a senior college class of 500 students, 500 students, 210 smoke. All right. Good for you. That's wonderful. 258 drink. 216 eat between meals, as if that's a problem. Eat between meals. 122 smoke and drink. 83 eat between meals and drink. 83 eat. I'm just going to say eat and drink. How about that? That's easy. And 97. I'm sorry, 97 smoke and eat. And 52 are all three. Nice. Hey, we're going to make a Venn diagram. Cool. Let's do that. So here's my Venn diagram. Everybody in the box adds up to 500. Wee. Smoke, eat, drink. Okay? So in the middle, 52. Nice. Now, smoke and eat. Smoke and eat is 97. That means this is 45 for a grand total of 97 in here. How about eat and drink? Eat and drink is 83. That makes that 31. Smoke and drink is 122. So that's 70. And then total smokers is 210. So 210 is, I'm just going to do this. Oops, I'm not going to take the log of it. That's weird. 210 minus 45 minus 52 minus 70 is 43. There are 43 people who only drink. But everybody in the circle smokes. All right. I'm sorry. 43 people only smoke. That's what I meant to say. Sorry. As far as eating goes, that's 216. 216 minus 31 minus 52 minus 45. 88 people eat. And drink is 258 minus 70. Well, I'm going to do minus 122 minus 31. 105. So then, of course, the question is, how many people do all three? Now, the easiest way, how many people don't do any of them is what I'm going to say. So let's do this. People who eat, or let's do it to people who drink. So the drinkers are 258. So if I start with 258, that's that bottom circle. I'm going to add to that 43, 45, and 88. That's 434 people. The rest of the population is out here. Well, you know what? This guy here, he's skinny, he doesn't drink, and he doesn't smoke. I know he's skinny because he doesn't eat between meals, apparently. Whatever. Nice. Now, that's what our thing looks like. What's the probability that a person smokes but does not drink alcoholic beverages? So, smokes, that's going to be 88 people who smoke. You with me? There's 88 people who smoke, but they don't drink out of 500. Okay. By the way, how would you say it? That's smoke and eat complement. Eats between meals and drinks, but does not smoke. So eats, drinks, but doesn't smoke. So eats, drinks, but doesn't smoke. There are 31 of them. They say eats between meals and drinks, but does not smoke. Exactly. Neither smokes nor eats between meals. Neither smokes nor eats between meals. That's only the drinkers, my man. So there's 105 of them, sure. Oh, but groom. What about these guys? Yeah, them guys too. So that's 171 out of 500 that neither smokes nor eats between meals. Perfect. Okay. Let's bust out a couple more for fun here. Just so you feel comfy on it. Nice. Oh, sure. A pair of fair dice is tossed. What's the probability of getting 8? Probability of 8. And what's the probability that at most you get is a 5? Oopsie daisy. At most, a 5. Okay, a couple ways to do this problem. I like listing out the sample space. To me, it just makes me happier. You don't have to. My problem if I don't is I end up losing somebody. Now I've done it often enough. It's harder to screw it up anymore, but it's possible. 2, 3, 4, 6, 7, 3, 4, 5, 6, 7, 8. 4, 5, 6, 7, 8, 9, 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10, 11, 7, 8, 9, 10, 11, 12. There they are, 36 outcomes. 6 on one, 6 on the other. 8 is 1, 2, 3, 4, 5 out of 36. Okay. At most a 5. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 out of 36. Okay. Now you can do it differently. Of course, you could just find probably get a 2. It'd be a 1 and a 1. There's only one way to do that. Yep. Probably getting a 3. Well, you can get a 2 on the one dice and a 1 on the other. Or 1 on the first dice and a 2 on the other. Okay. And I know what I'm doing now. I've done it long enough to where, oh, yeah. But other times you're like, bro, I need to see my sample space. It helps me out. Okay. I hope that helps. Let me know if you need more. Glad to do more for you.